started. Welcome back to weekend number 3, the last weekend of the Object-Oriented Programming in C++ course. Hello. So, what I thought I would do is just start the morning off with the final exam review. For those people who showed up on time, you will have privilege to knowing what's on the final exam. I also have some fun activities for you today and tomorrow to make up any extra points that you might not feel comfortable about on the final exam. So I put together some in-class activities for you to do, so it'll be a little less boring for you. I will also reserve some time for you Sunday to study. So the way we're going to work on Sunday is that we'll meet here at 9 o'clock in the morning, and then we'll go till noon. And then from lunchtime, after you get back from lunch, you'll have the exam at 3 o'clock. I'll allow you several hours of study time from noon to 3. So you'll have some time during the day on Sunday, right after lunch, or you could spend your entire lunch studying if you wanted to prepare for the final exam. And the final exam will be given at 3 o'clock on Sunday. There's no way, the administration schedule set, there's no way I can change that at all. And then today, I will lecture in the morning, and then in the afternoon, you'll have some opportunities to perform some in-class that will be emailed to me today. Means you have to do them today if you want the points for it today. Opportunity to pick up 15 points. Because some of you are going to fail the final exam. It's programming, it's multiple choice, and I'm going to go over the exam. Not everyone is going to pass that exam. The exam is actually quite challenging. So instead of putting the pressure on it, you can pick up an extra 15 points by doing the in-class assignments. And if you do that, then you can take off some of the points. You can relieve yourself of some of the stress. I think I might make it actually so that those 3 assignments that I'm going to give you could well, I'll make it so that they're due at 3 o'clock tomorrow. So you can work on it tonight, you can work on it today, because that's kind of stressful to have to turn it in today. The EMS is already done accepting assignments. Everything is locked. Everything is overdue. If there was a technical issue, and only in rare cases of technical problems, if you can show that there was a technical problem, and the EMS was unavailable or gave you an error message or something of that nature, or you submitted it, you got a confirmation but it's not showing, we can make technical corrections. However, there's nothing else to be done with the EMS. If you're late with assignments, you're late with assignments. There's absolutely no way of accepting late work. So we're done with the assignments. They were due on Thursday. So right now all you have to do is take the final exam, get through this weekend, and you're done with this course actually. So it's we're definitely down on the tail end of everything. So after I go through the final exam review, we will have a short break. I'll go over the assignment, the first set of the assignments. There's 3 in-class opportunities. You can play around and watch YouTube videos and ignore this completely and then take your chances on that final. Or you could work on the 3 class activities. If you work on the 3 class activities, you're going to be doing some programming. Yes, there is programming on the final exam. So you'll be able to study using the in-class assignments. So if you perform the in-class assignments, you'll actually be doing the things that you'll be doing on the final exam. The assignments are pretty much geared towards final exam content. So it's not like a waste of time for you. It's actually a better way of studying than reading a book. So if you choose to do it, then you can pretty much fail the final exam and still end with an A in the class because you'll have 15 extra points. The exam's worth 25 points, I believe. So you'll have more than half of that exam taken care of for you, and it adds as bonus points, extra credit. So it's not going to help you very much in the case in which you haven't turned anything in, but if you've got all your assignments in, you've got everything ready to go, and you just don't test well, it'll definitely make it so you haven't failed the final. So, questions about this weekend, the schedule, what we're going to accomplish, anything like that? All right, let's push forward ahead on this final exam review. This is what we're working with. So it's multiple choice, true, false, and some minimal programming. Well, let me take a look at this exam, actually. I have it with me. The exam is printed, and I told Joel to print it all on one side of the page, actually, because when he does it on both sides, there's not enough room to write. The exam is a 1, 2, 3, 4, 5, 6 pages long. And it is not multiple choice. In fact, if you look, you can see it. You can't look at. You can probably see from the distance that you're sitting. I can't read the words unless you have really good vision. But I'm practically going to read you the questions anyway, so it doesn't really matter. You've got, you know, a whole paragraph, and then you got some blank space where I'm expecting you to write some source code. So you'll have to write some source code. It's not just multiple choice true false, because, well, it's just too easy when it's a programming course. How are you going to take a programming course and not write any programming source code? So you'll have some opportunity today, however, to practice, refresh your C++ writing skills so that you can write on the exam. So we have 2 questions on the front page that are programming questions. I'm just giving you the rundown right now, then I'll go through topic by topic for you. Starting with the second page with question number 3, we're looking at 1, 2, 3, 4, 5 multiple choice questions. You got some multiple choice on here. It's not too bad. And number 8 is kind of like one of those short answer questions. No programming, but it's not multiple choice. You actually have to write something. And then we have one of those, you know, where you have those questions that say, match up this with this. And you got like A through E over here, and you got like a bunch of blank sentences over here, and you have to put the numbers in there. One of those kind of questions. And then we have a couple more questions that ask you to write programming stuff. Two more questions down here. Very small questions. It's like 1 or 2 statements of programming code. And then we got a question, a couple multiple choices filled in there. And a couple more little, you know, questions about programming, but it doesn't really require you to write too much. A couple of the questions actually show you a piece of code and ask you some questions about it. So there's a lot more of the coding component in the exam. So you'll have to look at source code, identify what the source code is doing. And obviously the source code that you're looking at in this particular example has to do with the concept of pointers, but I'll go over the concept in a few minutes. Because those lend themselves to really good questions, you know. You can look at a pointer code, follow through the logic, and then figure out, well, what's the end product? What's at the memory location? And then you can figure out, you know, it lends itself to a pretty easy type of question. Well, the bus must have let out. So, all right. So, and then in questions 16, 17, and 18, we're looking at more pointer questions. There's a lot of pointer questions on here. The last page of the exam, you are answering some questions with some words, and then you've got 1, 2, 3, 4, 5, 6 more little half a point true-false questions. So you do have a variety. You do have some true-false, you have some multiple choice, and you have some minimal programming stuff on the exam. So it is definitely not a boring exam. So there's a little variety in there. So what's going to be on this exam? We'll take a look here. This is also posted on the bhacker.com website. It's called Final Exam Review. If you take a look out here on the website, we will see it. I just put it up maybe yesterday or the day before. Summer 2013 Final Exam Review. That is what I'm going over right now. Topic by topic, let you know what's on it. So I'm going to try and hopefully go through it on the slow side, but if I have gone through too quickly, let me know, and I can slow it down a little bit. So topics to be covered. As you might imagine, structures and unions and classes. So C++, well, object-oriented programming in general is all about the object. Object is implemented in the form of a class. But we also have that concept of structures and unions that are kind of particular towards C++. They don't exist in Objective. Well, they do actually exist in Objective-C, or in C actually, because they're dialects of C, not really C++. The concept of inheritance, object-oriented programming, pointers. You'll have to write a class and you'll have to write a structure. So that's a no-brainer. If I'm going to have you write something, what am I going to have you write? Probably a class or a structure. You know, or a union, you know, so you want to be able to write those. But you'll have plenty of practice this afternoon to write some of that stuff. So let's talk about the structured data type for a moment. If we remember from the first day, this is also our review of the course at the same time. So if you remember from the first day of class, first thing we may have actually looked at was the structure. The structure is a compound data type, they call it, or complex data type, because it contains multiple data types inside of it. As an example, the structure that we call a person And the person structure could have a first name, a last name, a date of birth, an age or something. It has different pieces of information in there. And so we take all those different variables and we put them inside of this new user-defined data type that we're creating that's called person. And then we make instances of this person structure. Well, in object orientation, we call it an instance. In C, where structures actually come from, we actually make variables that are of structure type, which is interesting when you think about it, yet it's kind of like the predecessor to C++. So the syntax is the same as a class. So we say struct struct space person, and then we have an opening bracket and a closing bracket, and we stick everything inside of it. Structures, believe it or not, you can define variables, and you can also put functions in there, which is actually kind of interesting. Most people don't put functions inside of it. I'm not going to have you put a function in there. Instead, you're going to put variables inside of it. Your class that you're going to make are going to have some methods, because you're going to have to create a class as well. But anyway, long story short, by definition, this structure is kind of like a class. It doesn't actually have any of the inheritance qualities of a class. We don't build structures from structures, but we build classes from classes. So the structure was around in C, actually comes from C. C++ made the structure into a class, gave it object-oriented features, turned it into an object, gave it inheritance, polymorphism, encapsulation, did all that other stuff to it. So definitely turned it into something. So by definition, it's a type which each value is a collection of components, items. So there's an entire collection of everything under one name. And we call the structure a person, and it has a collection of a couple of integers, a string, and a couple of other items. So know what's meant by structured data type. You actually will. This is wrong. You may actually need to. So you might actually have to create a structure for the final exam. That's wrong. So we all started out with the structure, and then we figured out, well, how do we access members inside of the structure using the dot notation? So you'll have to use the dot notation because you'll have to make a structure variable and then set the name or set the age or set the telephone number of that variable. So in doing so, we're looking at the dot or the period, the point. So it's a member selection operator by definition. You don't really need to know the terminology. I'm not going to ask you questions like, what is the member selection operator? You're going to probably already know what that's meant, what that means. But anyway, I want to basically find out, can you use it? Do you know what it means? We know there's two of these guys, one for pointers and one for non-pointers. The non-pointer version is the dot. The pointer version is the line and the arrow, the larger than arrow. It's two symbols, which is kind of weird, but it looks like one. It's a little arrow that goes in there. It's done the same way, used the same way. It's just one is a pointer variable and the other one's a non-pointer variable, because we have pointers in C++, and so when we use the member selection operator, we want to be able to tell the difference between the two. Well, it does a slightly different operation, so it's important to keep track of the differences. So after the structure type declaration, various different members can be used, and we can run methods and classes and on classes when we use the member selection operator on an object. So here's some examples down here. This animal dot weight, another animal dot country. So from the animal example. So what we have also are some questions on the final exam that deal with object orientation, because this is object-oriented programming in C++. So we have the API acronym that starts out with A. So A-P-I-E, pi. If you've never heard of it, that's a good way. It's a mnemonic to memorize what are the four components of object orientation. Well, it's a pi. A-P-I-E. And I go, okay, if you got that far, then you go, what does the A mean? Abstraction. What you're looking at on the slide. The P is polymorphism. The I is inheritance. The E is encapsulation. I'm not going to ask you what a pi is, but you want to know the four components. So know what abstraction is, as an example. So an abstraction in object orientation is the representation of the object, actually. But it's taken the real world and turning it into objects or components. And then we have an object that represents a chair or an object that represents a person. So abstraction is a separation of the essential qualities of an object from the details of how it might work or how it might be composed. Once we create, in fact, the abstraction of the structure, you create a person that's of structure data type, that's an abstraction, because then you use the person, and you go person name, person age, and you treat the person like an object or like a, well, like a concept. It's an abstraction, but inside of the person you have all this other data that you may or may not be using. It hides the details. We don't need to know. We don't have to write and define what we mean by a person every time we create a person variable or an instance of an object or something called person. We just use the abstraction of it. So that's really what's meant. So it's focused on the what, not the how. What is that object? What does that object represent? Not really how it's implemented. So it's necessary for managing large complex software projects. It makes it easier. You take the whole program, you narrow it down using abstraction, and then you've got an easier representation of it. Easier to understand. Which, if you think of the concept of abstraction, and what's that doing, that's why we call these abstract data types, because they're abstract, but they're also user-defined. So in other languages, they're called user-defined or programmer-defined data types. In object orientation, they're abstract. Oh, looks like we're going to have attendance, so let me put this on hold. All right, so sorry about that interruption there. We are now ready to resume. So let's see, I was talking about abstract data types, and so the abstract data type is really the programmer-defined type or the user-defined type. So it's a programmer-defined type with a set of values that are allowable operations for the type. Well, if you think about a data type in general, data types are defined by two components. One is the values that you can assign to the type. The other one is the allowable operations for that type. So when you create a class, as an example, you're creating your own abstract data type. A structure as well, same concept. On a class, you have data members and member functions. So you're creating what data that the class is holding and what valid types the class can hold, as well as which methods. And the methods are the behaviors or the operations. So you have that data, and then you have the operations or methods and data members and member functions that you're working with. You also have the same thing with structures, actually. So structures have that in common. Unions, not as much, because a union is defined by a lightweight structure. So for those of you who may not be familiar or who have forgotten, because this is really, hey, what about C++? Let's refresh our memories this weekend. The union is just like a structure, except for only one piece of memory is used at any one moment of time. So they call it a lighter weight structure because it doesn't take up as much memory. It only takes up one memory location. So it's either going to hold it. Why are they talking in the hallway? Maybe I can shut that. Would you guys mind shutting that door? I'm sorry. It's just a distraction for everybody. So if we can shut that. Can you please? Thank you. If it gets too hot in here, actually there's not that many people in here. It seems pretty light right now, so if it gets too hot, we can always open up the side door. But much better, thank you. That way the people in the back, because I know people are wanting to listen to this review. Otherwise you can't. You're not going to know what's on the final, so it's kind of important. So I'm glad I have your attention, actually. So very good. All right, so the union, if I were to ask you a question on the exam that says, what's the difference between a union and a structure? They really are the same thing, except for a union is only designed to hold one piece of data at a time. Structures and unions can both have operations, and they also have allowable data types. So you can have functions inside of a union, and you can have data inside of a union. Same thing that you can have with a structure. However, in modern day programming, people don't do that. They just define a class, and then they use the class with the data and the member functions. And because the class has got more features to it, I mean, it's a higher level. So you can do it with a structure. You hardly see that, though. If you're going to spend all that time making those structures that useful, you might as well turn it into a class. So anyway, so and be able to define C++ and, using structures and using classes in terms of how you're going to implement. So if I asked you, how are you going to implement an abstract data type? in C++, you're going to use a union, a structure, or a class as your options there. You know, things like type define are good, and enumerations are good, but as they really abstract data types, they kind of loosely fall into that category. They're just programming constructs that allow you to rename types or change types around. So in terms of the implementation, what is meant by that? So it's using a specific data representation for the abstract data type. So looking at built-in programmer-defined types, well, we have data members. Know by concept, all user-defined abstract data types are made by primitive data types. So going back to day 1 of this class, primitive data types in the language are int, float, double. You know, actually, string isn't. String is an object, but a character array is. I'm not going to ask you what's a primitive versus an abstract. I'm not going to get into that much detail. Instead, in concept, you can use that if I were to ask you a question that says, you know, how are abstract data types implemented? Well, they're implemented using primitive data types. And you are creating data types from existing data types. So are you really creating anything new? Yeah, you are. You know, you're creating a class or a structure of something, a person, and it represents an object, and it has the data, and it has the member functions. So we have data members, and then writing the functions or the member functions for each one of the allowable operations. That's your functions or your methods that are being used with that. So you write methods or functions, and the functions are used to allow the operations on the abstract data types. So we have this concept of information hiding. Now, it wasn't part of the PI acronym I gave you, but it is part of the PI acronym. If you think about the concept of abstraction, it gives us information hiding. We also, so a lot of people complicate this and they go, well, I gave you a PI, and then they go, well, what about information hiding? And then what about reuse? Isn't object orientation all about reuse? And isn't it about, anyway, so long story short, those two concepts, reuse and information hiding, are incorporated inside of a PI. They're inside the PI already. So in terms of the information hiding here, the interface gives us the information hiding when we include iostream.h or we include string.h. That's actually a form of information hiding. We're using the header or the public interface. The public interface hides the details of the object implementation, gives us a higher level abstraction of the concept, just tells us what's available so that we can use that without having to actually even look at the class. In fact, I guarantee it, nobody in here has probably actually even looked at iostream.h or iostream.o is the object that's created, or iostream.c++. Although you've all used it. If you've done C in and C out, you've used it, but you probably have never looked at how C in and C out are actually implemented, unless you've overloaded some of the operators, and then you can kind of go, oh yeah, IO streams, stream. And then you start thinking, oh, this is stream to input, stream to output. Oh, wait a minute, maybe that's why they call it IO stream, you know? Or anyway, long story short, it's all been hidden from you through the interface. So class implementation, the details are hidden from the client's view. The client is the user. So I remember in the beginning, also what I'm doing is actually going over the first weekend that we had together. And the first day of class, I talked about the driver program, and I didn't call it client. I don't like to use the word client. What I'm really talking about is the driver main program. Main makes instances of all of the objects. So we have public interface to main, which is meant by the, main. It was usually public void or public int main something or whatever. We basically give it a data type, and we give it an access type. We usually say public. So we can inherit things as public, private, and protected, and then at that point I talked about all of the different access methods that we have within a class. Long story short, main is normally the public interface, because if it's not public, how are we going to be able to use or see anything? We can't. There's nothing there for us. But inside of the classes, we keep all the data private, and then we make the member functions public, so we can access all the data that's inside of the class, because we don't want the public to access all the data that's in there. It's like me going over to you and saying, hey, I'm going to change your name for you. You're like, wait a minute, you can't change my name. Or here, I'm going to give you a different student ID. What? Which some of you might want at this point, who knows. But long story short. you know, it's like protected data. You're not going to touch that. No one, in fact, hopefully you're not going to give out your social security number either. Or, you know, you're probably going to give out your student ID. That's pretty safe. You need that for certain things. But long story short, it's data. So there might be a form that you fill out, and there's a check that says, you know, am I going to allow you to give, or am I going to give you my social security number? Well, if it's on the form, I'm using a method for giving that to you. So I'm going through a process of thinking, are you allowed? Should I be giving it to you? I'm making my decision on whether or not I'm going to give it to you through the method, which is how the class thinks. And the object thinks, well, let's see if it's okay. We have a public method that will display that social security number for you if you're the government, or if you're authorized, or if you're, you know, but, you know, are you going to go and take all your credit cards out of your wallet and show it to the homeless person on the street and say, here you go? You know, you're probably not going to do that. You're going to have restricted access to that, which means you're going to have some check to say, well, who is that person before you show it to them? But anyway, long story short, here's the interface between the client code, aka main code, and the object itself. So we have the specification and we have the implementation. The .h file is the specification. The .c++ file is the implementation of the .h public interface, which also deals with this concept. So we break each class down into two files. We have a .h and a .c++, and hopefully you did this for the assignments that you turned in already, so this should be a huge review for you. Benefits of information hiding. The details and the data can be concealed from the client of the abstraction. So all the information is hidden and the client is not going to have access, or the main method. The public isn't going to see your social security number unless you want them to see it. And the code can be changed without affecting the client because the specification and the interface are unchanged. So with each new version of IOStream, the .h file always stays the same. We've had C in and we've had C out for years, actually. Just like we've had printf and scanf for years with stdio.h, which is the C version of that. But I guarantee it, over the last several years, with every new version of the Microsoft Visual Studio, we have different implementations, bug fixes, with different types of monitors now, different types of input systems, different type of output systems. All that stuff has changed. The object itself still exists. The public interface still exists to it. We still have this function and that function and that function. But the entire implementation has been modified. So we can do that and we can remain consistent, which is what the slide is referring to in terms of being able to change the code without affecting the client or the program that was working with it. So if you build your object-oriented program and you create it in a modular format there with the .h interface and the implementation files, you put the whole system together, you decide, oh, something's not working right, I'll just change that one file, recompile the object code, link the whole thing back in together, and then voila, problem's fixed. If you can find the right object to change. If you can't find the right object to change, then you're hosed anyway. But long story short, you don't have to rewrite the whole program. You just change one little object and replace that object. So a lot of the updates are replacing DLL components or pieces of the object code. So as I mentioned before, you can create, you know, object code is linked. So in a compiled language, I may or may not have mentioned this actually, but in a compiled language, we take, you know, we have main, and then we have, and that's going to be in a driver program, and then we have a person object, and we have an employee object, and a staff object or something. When we compile this all together, we have a .o, a .o, a .o, a .o. They're all .os. They're all objects. And then the linker takes all the .os, puts them together, makes an exe file out of it. Well, if we want, we can take and say, well, I want some flexibility with this. I don't want it all compiled into one exe file. We can take one of the .os, turn it into .dll, and then link it from a .dll perspective. Then we don't have to recompile anything. So when you update Windows, Windows is performed this way. So when you update Windows, you just replace a DLL. You don't have to replace the entire operating system. Everything's separate. Everything's outside of it, which, you know, is dynamically linked instead of statically linked. So the .o and the linker from the linking stage of compilation statically links everything together. It means it takes that .o code, copies it into the executable. The executable's got everything in it. When you do a DLL, stands for dynamically linked library. You take the same library, convert it to a DLL format. the linker makes a linkable path out to memory, and you register it, usually with a registry or some other form of registering for it. And then it goes and looks for it. Maybe it's in a particular directory, maybe it's in a particular memory address, depends on the addressing scheme, depends on the support and how you configure it. But long story short, you're not linking it inside of the executable, it's linked outside, so it's dynamic, which means at runtime, dynamically gets put into there. That gives you a better object-oriented design, because then you really do have a modular system, and you can just update that DLL whenever you want to. And you know, just reboot the computer and it works. You know, just going to link the brand new DLL in there. You don't have to recompile the whole thing. So, all right, a little tangent on DLLs, but if you've never heard of the concept, that's what's going on with that one. Okay, so here's an example of the class time type, and this is the specification, or the .h file, which it says right up here. And in the specification file, we can have class time type, and then we can have public with some methods, private. And here you might see this upside down. The way I like to do it is I like to put the data on the top, and I like to put the member functions on the bottom. It doesn't really matter. You can do it any way you want. In fact, a lot of people, for some reason, like, well, I know why. If you put the member functions on the top, then that's what you're really looking for. You forget, what's in that class? Then you open it up and you go, oh, here it is right here. Then you don't have to worry about the stuff on the bottom. You know, I don't know. We can't touch that stuff anyway. It's hidden to us. Let's just put it on the bottom of the file. And this is all on the top. So, long story short, there's two sections. Know that there are two sections. Do there really have to be two sections? Nope. You can actually put them all together. There's only two sections here because we have one that's called public and the other one's called private. We don't have to put a space in here. The slide looks like, no, there's a space between the word private and the colon. Don't need a space, actually. But we put private, we put public on there. We put a colon on there, say it's in a directive that says, okay, here's the list. And then it looks for another one. If this doesn't exist, the whole thing is public. So if we put public up here, which is the other reason why some people like to put the data on the bottom, which is kind of ironic, actually. By default, everything's public, I believe. Private, excuse me, by default, I'm sorry, I'm looking at the methods. By default, the member functions are public, and the data is private. This is turned around backwards for me. I want to see this up front. I want to see this on the top. Because by default, the data is private. The member functions are public. Because how are you going to run something? In a current version of Visual C++, I tried it out the other day, actually. They changed the rules. You may also think of this, everything is private. Except for the compilers keep changing the rules. If you rely on compilers to make up your programming syntax, you're going down the wrong route, because, as an example, now everything's been changed. Everything is being weird. They're trying to think too much for you. But yeah, in the old days, the original format was everything's private. You're going to make it public, then you put public in there, you make something public. And if you're going to make something public, you're going to make the member functions public. So what I told you from object orientation, what you need to know for the final exam, data members are always private, member functions are always public. The defaults, I'm not going to ask you about the defaults, but the defaults, if you want to memorize defaults, make them all private. But there's no question it's going to say the default, because that's arbitrary. Default for what? Default for Borland, the default for Dev, the default for Visual C++. You know how many versions of C++ are out? GNU C++. GNU doesn't make anything by default. So if you want to make your code more compilable with different compilers and more standard, specify what you mean. You don't specify it, then you're relying upon defaults that are built into the system, and then what year is your compiler, what are going to be the defaults. So actually at one point there was a version of Visual C++ where everything was public, and then there was a public and then private, and then everything went private, and then everything's now back to public. I don't know what the defaults are these days, but know that the data is supposed to be private because you're protecting it. So this is actually called access modifiers. Modifiers. So you're modifying the access method because the access method, by default, is something. So you modify it by specifying the access method. So I don't know. It's convoluted, but know the difference between public, private, and not listed on here. What about protected? Well, protected, this is an easy one actually. It's not public or private, but it's both. So it's private to main, but it's public to inherited classes. So if you put protected in there on a base class and you inherit a class from that class, then whatever is protected is public for the derived class, but it's still private for main. So people like to use protected because they don't like to, well, we have this friend concept that I went over, and we actually talked about friends. I remember this friends because I think Dr. Real came into here, I think. Was this the class? Yeah, and he says don't make friends with C++. He's actually true, don't make friends with C++, which is actually kind of a humorous joke, because this is the only language you can make friends with. But why are you going to make friends with it? You're going to violate all the rules when you do that. When you make a friend method or a friend class, it's private to everybody, but not to you. So you're breaking the rules completely. Instead of making it private and having the rules consistently applied towards all of the different scenarios that I've been going through. You make a friend out of it. All of a sudden, in this class over here, it has nothing. It's not even inherited from that class. It's not the main. Can just go ahead and use all the private stuff of another class that's made friend. That's made available by friend. You're like, well, why do you want to do that? So don't make friends with C++. It's really a bad idea. But they do come in handy for certain things, especially when you're overloading operators, overloading methods and stuff. Overloading operators is common to see friends, but or you're trying to implement something in another class that doesn't belong to the hierarchy. We know that C++ supports multiple inheritance, not like Java. Java has a single line inheritance. You don't have to know this, it's just trivia, but Java has a single line inheritance and then it has interfaces. So one class extends another class, but it implements interfaces. C++, it just extends. Some of those classes are abstract, some of them are not, some of them are really interface classes, but there's no such thing as an interface in C++. So but there is. It's just convoluted. So anyway, long story short, I'll review that in a few minutes. But know your access modifiers, public, private, and protected. So the use of the C++ data type for the class type facilitates reuse of the C++ code for an abstract data type. Where do we get this reuse from? Well, once we create a base class, we can extend multiple other classes from it, and then we can use that throughout all of our programs. In fact, we can just keep a repository of those classes. Once we create a nice date class that we like, we can just use it for every program that we write. We need a date. Okay, date, my date is equal to something. Create a new date out of that for me. And then we can create new dates from the date class and not have to rewrite it all over again. So that's one of the ways that we facilitate the reuse. Also, remembering, you don't have to remember that it's called client code, but the main program can use anything as long as it's visible. Any class you created like 10 years ago, as long as it's compilable, it's like available still, you can use it in your client code. So client code basically sees everything, well, everything that's public. So variables of a class can also be called class objects or class instances. So knowing the instance of a class. So as I mentioned earlier, when we make a structure, we don't really think of making an instance of a structure. We make a variable of that structure data type. We usually talk about classes and objects as making instances of them. We're going to make an instance of this object. So anyway, be familiar with the instance terminology that's used all over the place. In fact, it'll tell you, make an instance of this object that does this, this, and this. Or pass the instance of the object, use the constructor of the object. Create an instance of the object using the constructor to do this. So if you don't know what an instance is, you're going to be kind of, what is an instance? Well, hopefully you know that by now. So, client code uses the public member functions to handle its class operations. So in using the class, a programmer defined class whose components are called class members can be variables or functions. And then the class members are private by default, and compiler does not permit the client code to access those private members. And the class members declared public form the interface, or the public interface, between the client and the class. So I kind of like why people call it the public interface rather than just saying interface. It reminds them, oh, it's public. So in most cases, private members contain data, and member functions are the manipulating the data. Other languages, we have facilities to create what's called setters and getters. We do that manually in C++, or you can actually do it yourself. Actually, there's tools. Some of your IDEs, in fact, I think Eclipse can create the setters and the getters for you automatically. It doesn't in Java. I think it does it in C++ as well, but I've never tried it because I use dev for C++. But long story short, what do I mean by setters and getters? Textbooks call them accessors and modifiers. You don't need to know that terminology. But a setter sets the information. So it says you have a class object, it's called person, it has first name, last name, and date of birth. And then you have setter says get name, get first name, get last name. Well, that's a get. Set first name, set last name. It usually comes in sets. So for each data member, you have a set name, and then you have a get name. One's the accessor, the other one's the modifier. So you're going to set the name, you're going to ask the user for a name. Hey, enter in your name. Or you have a function that says you're going to call my person dot set name, open parentheses, quotation mark, Barbara, close the parentheses, close the quotation mark, close the parentheses, put a semicolon at the end of it. And then you're going to have a method call that set the name, or get the name, prints it out to the screen. So be familiar with setters and getters. Also be familiar with constructors. So constructors exist in classes, and one class can actually overload or call a constructor of another class. So if I have a person, and then I have an employee that is extends the person, inherits the person, then when I make a constructor for the employee, I can call the person's constructor that takes a name, or takes a name and a age or something, or date of birth. So I don't have to reinvent the wheel. I don't have to create a new one. I can reuse constructors from previous classes I've created in the hierarchy. And a constructor by, going back a few minutes here, a constructor by definition automatically invokes when the instance of the class is created. You make a new instance, constructor goes off. C++ has 3 types of constructors. Other languages don't have, well, they have initializers. Some of them have an initializer and a constructor. C++, we got the constructor, we got the copy constructor, and then they got a deconstructor, or destructor. I call them a D. I mispronounce this word all the time, but I do it on purpose because I don't think it should be called destructor. I like deconstructor better because it's like the opposite of constructor. It's a deconstructor. So a constructor, and oh yeah, and by the way, none of these can be called. You can actually explicitly call a copy constructor from an instance of an object, but theoretically you're not supposed to call any of these. They get called automatically by the life cycle of the object. Object gets created. One of those constructors are going to fire. After the object is created, no more constructors are going to fire. It's already constructed. So constructor builds the object. So if you make a new instance of the object, go into new person, opening and closing paren, no parameters, you're calling what's called the default constructor. You write a default constructor in there. You can just say, hey, name is equal to unknown, age is going to be equal to 21 or something. Or, you basically put some fake information in there or some default stuff. Not set yet, or something. So that we know it's not ready, hasn't been assigned yet. And then the programmer would use a setter or a getter to manually modify the name and the date of birth or something. But it doesn't take on any arguments. The constructor that takes on no arguments is called the default constructor. Then we can have any number of other constructors that we want. So we can have 15 different or 20 different constructors. Usually you have a constructor for each combination of all of the data members. So if you have 3 data members, set all 3 of them in one, then that's 1. Another 3 constructors for each one of them individually. That's 4 total. And then 1 for both combinations of the 2 and the 2, 5, 6. And then the third, 7, 8. Long story short, you can just come up with all the different combinations, multiplying them out, and then you have a lot of constructors for that data. which is why a lot of your tools, Eclipse will do it for you actually. You just generate constructors. Generate setters and getters. Generate this and generate that, because it's kind of tedious. I'm not going to have you do that on the final exam. You don't actually have to create a constructor with all the different combinations. Instead, what you're going to do is you're going to get a question. In fact, let me pull out the exam real quick so I can read you a question. Of course, there's going to be some blah, blah, blahs in this question, but here's a question. Now everyone was listening before. This is a very attentive class. Now you're really listening now. I can't believe how quiet it is in here. It's just amazing. Write a class declaration named blah, 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 blah with a blah, blah, blah member variable named blah, blah. And then I say write set and get functions to access the blah, 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 blah. I don't know what more I can do outside of reading you the question. If you don't know what a set and a get, and if anyone comes up and asks me what a set and a get function is, I'm going to find it hilarious. Know what a set and a get, you're not going to forget this one. By osmosis, if you've ever used any language compiler, you know what a set and a get function is. But just in case, this is your first programming, this is the first time you've attempted to program and you plagiarized all your assignments and you have no knowledge of programming in general. A setter sets data, a getter gets the data. So we assign a value to a data member. We return a value that the data member contains. This is for the benefit of those people who like to borrow and steal and plagiarize source code and don't do any of your own work, just so you can pick up a few more points on the final. This is C++, by the way. No, I kid you not. Last time I taught this class, I had a couple people who wrote answers in Java. This is C++, not Java. And I can tell the difference. Actually, it's real obvious. You can tell the difference. I can tell the difference between Java code and C++ code, people. Especially with inheritance. That's question number one. Question number two. If I'm going to have you write a base class, this is a base class, by the way. Question number two is you're going to derive a class from the base class. So in question number two, it also starts out with write a class declaration named derived blah, 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 which is inherited from blah, 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 blah. I'm not going to give you the theme. Otherwise, what's going to end up happening is everyone's going to go out on the internet, you're going to stare at it for hours, and you're going to go, oh, this is what it looks like. And you're just going to write it down. I'm not giving you the theme. The theme's not hard, though. You're going to add data to this derived class. You're going to overload a constructor. And so you're going to want to know how to call a constructor from a base class from a derived class. You know, you put a little colon there and you go public. Excuse me. You pass the, well, I'll review this after. Anyway, let's start. You have the entire afternoon to write this because it's in a couple of the examples, a couple of the exercises that you're going to do this afternoon. Right now I'm just trying to review for the final. But know how to call a constructor from a derived class that is contained in a base class. So if the derived class was a person, no, excuse me, the derived class was an employee, and the base class was a person. The employee might have, if you made a constructor, might have an employee ID. May also have a first name, a last name, and a date of birth. And the employee would be holding on to the employee ID, and then would get everything derived from person. So name, first name, last name, and date of birth would come from person. So from the employee object, when you run the constructor, you're going to take on 3 parameters in this particular example I'm giving you. Employee number, first name, last name. Oh, maybe that's 4. Employee number, first name, last name, and date of birth or something. Then that would be passed back. So you'd take all those 4 from the constructor and you'd assign one of them in the derived class, and then the 3 other ones would, you go colon and you call the constructor of the base class that you want. So you can set it back there. So it sends it back. Because constructors fire in a reverse order. So the base object gets created first, and then the derived object gets created second, and after that gets created third, fourth, as we go through the hierarchy. And then it tears down in the opposite order, which is actually kind of interesting. So a constructor, going back to my 3 different components, so the constructor happens only when the object is created. When the object is removed, when it goes out of scope, when it's no longer being available, gets deleted, we have a destructor. The destructor or deconstructor deconstructs it. So that's in the deconstructor, you're going to put the delete this, delete that, delete this, delete that. So when you need a destructor, when you're allocating memory inside of the object. Otherwise, there's nothing to destruct, which is actually kind of interesting. So the copy constructor and the deconstructor are used with allocated memory inside of the object. So if you're not allocating any memory, there's absolutely no need for either one of those 2. Most classes will have a constructor regardless, because the constructor has this totally different purpose to it. Constructor is just being used to automate the creation of that object. So on a deconstructor or destructor, object goes out of scope, you delete the object. It's going to go in, and anything the object is allocated, it's going to go ahead and remove it. It's going to have a bunch of deletes in there. Copy constructor is only invoked automatically, implicitly, when an instance of the object is assigned to another instance of another object when it's copied. So if I said person A, comma B, A is equal to B, on an assignment expression, we got a copy. One of them is equal to the other one. Okay, so take this one, copy it over to this one. If I took A and I had it equal to B, and A was pointing to a particular piece of memory, then B would be pointing to that same particular piece of memory. So copy constructors are used to make new memory for the copy. So that's funny. The deletes, the deconstructor has a bunch of deletes in it. The copy constructor has a bunch of new this, new this, new this, news in it, because you're going to take, and copy constructors look the same as constructors, except it's a reference. So if you are familiar with operator overloading, if you do an assignment expression, the equals operator, you're actually overloading that operator with a copy constructor, because when one object equals another object, you're making you're using that operator. So a lot of people don't like copy constructors, and they'll overload the equals operator to do a copy. So the copy constructor, if you're going to do it, takes on a reference, and it's a reference to its same object type, because you're making a copy of yourself. So the only way you can tell the difference, because none of these guys have return types, by the way. Constructors don't have return types. So if we have a deconstructor or constructor, the deconstructor has a little tilde sign in front of it. So that's the only way we can tell, because a deconstructor does not take on any parameters. It doesn't get called explicitly, only implicitly when the object goes out of scope. You put a little tilde sign in front of it, and all of a sudden you got a deconstructor. Well, it's the same name as the class. No return type. So how are you going to tell the difference? Well, C++ goes, oh, well, this is really cool. The constructor can be anything. Just use the same name. The copy constructor is just a constructor that takes on an argument that's a reference type. So the parameter must be a reference type that it accepts. Then it turns it into a copy constructor. And then for the deconstructor would look just like a default constructor if it weren't for that little tilde that's in front of it. The tilde is like a little squiggly line. You put the tilde in front of it. If you leave out the tilde, it looks just like a constructor, and you just created a constructor instead of a deconstructor, which is kind of ironic. So remember the tilde. So if I asked you to create a deconstructor, make sure to put a little tilde in front of it. All right, so back to the constructor. So we have the access function or the observer. So it's a member function that inspects. So we have a constructor. We also have, this is the accessors or the modifiers or the setters or the getters go along with it as well. So we also have this keyword constant, C-O-N-S-T. So it makes it so that nothing changes. No side effects. Remove side effects or problems. If we're going to get something, do we accidentally want to change it when we get it? No. So we put that in front of the getters if we want to. You don't have to use that on the final exam if you don't want to. So just know if you see that on something, it means it doesn't change. Means like you know you can use the parameters, you can use the data, you can use everything, and nothing's going to be saved. So here's some client code or main program that is using this time type. So we have main, and we have two variables here that are declared. We have time type current time and time type end time. And time type, is that a class or is that a structure? It's class time type. Here it is right here. So time type dot h contains the specification. They call it a specification. It's specifying what's in there. We have what these things called function prototypes in here. Function prototypes are the the method signatures with a semicolon at the end. The specifications that include implementations. The implementation is the body of the method. So they have what's called an inline methods. Inline methods are performed when you put the implementation into the specification file. You do it in line, usually when it's one line of code or 2 lines of code or something. So the setters and the getters are sometimes done in line. You can do them in a, actually on the exam I don't ask you to even do .h or .c++. So imagine you're just doing the .c++ file. You're not going to have to do this at all for the source code. And the assignments you had to do this. On the exercises I'm going to give you later today you'll have to do this, but you don't have to do this for the final. I'll be lucky just to see an implementation from you, hopefully. Some of you will give me beautiful implementations. Some of you will give me Java source code. On a C++ exam, yes. Actually, somebody sent me Java files. Somebody sent me Java assignments the last time I taught this class too. I'm thinking, don't you know this class is C++? I'm like, you can't tell the difference. I guess that student couldn't tell the difference. You know you're in trouble when you can't tell the difference between C++ and Java. You're not prepared for the final if that's the case. Alright, so that might be a fun class actually. In fact, maybe we should have this class at ITU. It'd be like the difference between Objective-C, C++, C, Java, put C# in there, I don't know, throw a couple more languages in there. And the whole class is about all the differences between all the different languages. And then Dr. Real can teach that class, because he'd love it. Yeah, he'll go, oh, Python, we'll put Python in there. But then that would be a good class for most students to take, because then at least they knew when they were submitting assignments what language it was in. Alright, I'll stop being mean. No questions on namespaces either, but we saw this namespaces in the first couple weekends using namespace. Namespace is an environment, and the standard namespace std includes iostream.h. The funny thing is we don't include it. In some compilers, we don't get access to it, even though we've included, I was going to say import, when we include iostream.h. I mean, unless we put the namespace in there, we get compiler errors out of that in some cases. So anyway, what are we looking at here? This is the client code. This is the main program. Client code meaning the main program here. And we created 2 instances, and then we're going to run current time.increment, and then we get current time.equal. And what we have here is no use of pointers and no use of the word new in here. We have 2 ways of initializing. So this is a static initialization or static reference. So we've said time type, current type. We made an instance of the object statically. Static because it's just like saying integer I. I is equal to 1. Time type, current time. Current time dot set it. Get it. current time, if we didn't have private data members, we could say current time dot time is equal to something. We can set data inside of it if it wasn't private. This one is private. So these are what's called static references. Dynamic references. If I said new time space current time is equal to new time type. When I use the word new, I've created a piece of dynamic memory. If I've done new, I can do delete. So this is called static because it's statically allocated. It actually ends up on the runtime stack. It's stack allocated. Dynamic, it gets created with new. It goes up in the heap memory. There's no stack entry for it. It outlives the stack. It outlives the execution of the statement that created it. It's available everywhere. So there's a few differences with the scope. You can send the memory address to a function without sending it to a function. You can use it by reference. You can actually use these guys by reference too. But there's two different ways of doing it. One is static, the other one is dynamic. So new, delete, or the dynamics, I'll review that when we look at pointers in a few minutes. But the class declaration here, the class declaration does not allocate memory. This allocates memory when we make an instance of this object. And if we do new, we're going to allocate memory. If we do new on the object, then we can go delete on the object. If we delete the object, then the destructor will run inside of the object if we put one in there, if that object is allocated something. But the delete on the main object doesn't delete any of the other data that might be pointed to by that object. So that's why we have that destructor in there. Destructor does fire automatically when you delete the object. You also have cases in which you use the, you call the function. Inside of the function, you created an object, and then you left the function. Well, then it's gone out of scope. It's no longer visible. Anytime it's gone out of scope, no longer visible, the destructor will fire as well, because the object is going to be destroyed. If you create the object with new inside of that method, so you inside of the function. So you create a function. Inside the function, you said new this, new that, new everything else. Then you've created a memory leak because you're going to end the function. You're going to go back to the main program. All that news were done. All that stuff's still there. But now it's inaccessible. So inaccessible objects create memory leaks. So they always tell you, delete it if you do new. So new and delete, think about it, they come in pairs, or they're supposed to. If you do new, you're supposed to delete. So I'll review that a little bit more when we get to pointers as well. Alright, so class type declaration does not allocate any memory. When you create class, person, no memory. When you create the instances, it does allocate memory. Client code still needs to declare class variables. Make references, class references. I don't like to call them variables, but technically, that's a variable. Time type is a data type. Current time is a variable name. That's a variable. If I were to create a reference out of that, I go time type asterisk current time is equal to new time type. I left out the asterisk the first time I said it, but there's a little asterisk for a pointer. If you're going to use new, you're going to have a pointer variable with that. But long story short, that one's dynamic. I call that a reference because it's dynamic. And this is most textbooks would call this a variable. But I hate calling object instances variables because I would actually just create it as a reference. But technically, I think that is actually a reference, but it's really a variable. So I'm not going to ask you the difference between a variable and a reference. I'll save that one for Dr. Reel's class and the comparison of all those different languages. So that's going to be a hard class if he ever teaches it. C++ data types represent an abstract data type. By definition, there's two types of class members. We have the data members and the function members. Alright, so I call them data members and member functions because I think that wording sounds kind of weird. Or you could just call them data and methods, or methods or functions. So I have class members that are private, data members that are generally public, that are private. Data members are private, class members are private. Same thing, they're talking about the same thing. So public members are public, member functions. So I already went over that. So we have the aggregate class operations that we can do. They're built-in operations that are valid on object types. So we have the member selection using the dot as we've seen before. We also have the assignment. So we can assign one object using the equals. That's when we're going to get a copy made. We can use them as pass to a function as an argument. We can pass them by reference or by value. And we can return them as a value of a function as well if we want to. So objects can be returned from methods or functions. They're going to be actually in a copy constructor returns the object. I mean, if this one's going to be equal to this one, you're going to take this one of them as a reference that you're going to try and copy, and then you're going to return a copy. So you're going to return an object. So know that you can return them. Other operations can be defined by the class member functions. So if you have two people variables, just like if you have integer A and integer B, A could be equal to B. If you have person A and person B, well, A can also be equal to B. The same thing holds true. So here we have the two separate files that are generally used. We have the .h and the .c++, and then here's really the differences between the two of them. And you probably already know this, I hope, especially if you did the assignments yourself. You know, you're only going to make one class declaration. The funny thing is I'm waiting. I don't think I'm going to find it funny when I do the grading for this class, but usually I do get a few laughs out of some of the stuff that I see. I look at that and I go, oh, that is really funny. Because like what some students will do is they'll create a .h and then they're going to create a .c++ file and then they'll reduplicate the class. So you see this, I highlighted, it says class time type, and I see it down here too in the C++. I go, wow. So I wonder if that really compiles. I was like, no, it's not going to compile. But not half the stuff doesn't compile anyway. But long story short, and that's why I don't even try to compile anymore. I just look at the source code. Half the stuff isn't going to compile. But, I mean, I'm not saying that you didn't write perfect code. You probably did. Oh, actually, the people that were here at 9 o'clock in the morning probably wrote perfect code, and they probably did everything themselves, and they showed up on time, and they're like going to get an A in this class. It's everybody else who's going to have like I'm going to find their interesting, humorous examples here. But long story short, you only declare it one time. You declare it one time. If you're going to separate it out, you're going to put it in the .h file. C++ file is nothing more than a bunch of implementations. And how you know you're going to what you're implementing, if you don't put the scope resolution operator in there, you're creating a brand new one. So that's where those two colons come together in the C++ file, where you're going to implement the method body for the method that you actually created in the .h file. So that's all your implementations. There's nothing else. There's no class declaration all over again. There's no data in here either. It's just those member functions. So the C++ file just has the member functions in there. So here's our implementation, and here's that scope resolution operator. That's called the scope resolution operator. The dot is the member selection operator. Don't have to know the terminology, but that's what it means. So here's an example of a C++ file, timetype.c++. What you do for the final, don't do this. Just write the method. Treat it like Java, actually. If you want to write both, you can write both. If you're trained already, and you got both down, write both. Give me the .h, give me the .c++. Put a little line down the paper. One part, .h, the other one says .c++. And you just write the code, or better yet, you can put one on top of the other if you want. You can do it any way you want. I really don't care. So, some people are going, "What is she talking about?" Or don't put your Java code all in one. Then don't use Java code. All right. So what do we got here? Just a little method. It's going to return something. So here's the formal definition. It's called the scope resolution operator. C++ programs typically use several different class types. So different classes can have member functions with different identifiers. So in here, this is from time type. And know that the data type comes first. So it's bool time type, or integer time type, or float time type, whatever that happens to be the data type. Scope resolution equals the name of the method. Constants at the end of it, because we're saying we don't want this to change. You can leave out the word constant, forget about it completely for the final. You don't have to worry about it actually. But know that it just means that. Alright, so member selection operator is used to determine the class whose member function right is invoked. So we have this current time.right, number z.right. So class from time type, class from complex number type. If we inherited complex number type from time type, and we created instances of that. I think in the example up here in main, we created some instances. And we just have current time and end time. We didn't use it, so anyway, long story short, depending upon the reference that you're using, you're going to get a different time type. But here's how it's implemented down here. So in the implementation file, the scope resolution operator is used as in the heading before the function member's name to specify its class. So this is void time type scope resolution operator right. It means we're going to implement time types right. Which brings up the concept of overloading and overwriting. So I gave you an overloading example with constructors. Constructors are commonly overloaded. To overload a constructor or to overload a method, or we can also overload data, but that's a different concept. We're usually referring to methods. Methods are functions that are overloaded. The original is there. We're just complementing it. We've added more behavior to it. So when we overload operators, the original is there. If I overloaded the plus operator to add 2 points together, have I covered overloading yet? Or is it coming after that? Did I cover it last time? I think I went through everything last time. Because I knew that we were going to have this class meeting like right after the course ended. So, okay, good. I think I did overloading. Anyway, if I was going to overload the plus operator to add 2 points together, then I can add 2 integers still. I can add 2 doubles or 2 floats. The original behavior is still there. I just added new functionality to it. So remember, overloading just adds complements, adds new functionality to existing functionality. To overwrite gets rid of the original functionality, gets rid of it, replaces it with something else. So when we do this with data, we actually have 2 copies of it, but one's hidden. So in C++, we can actually hide the data. If we have in person, as an example, and this is a wrong way of doing it, don't do it this way. But in person, we have a first name and a last name, and then we inherit employee. We inherit from employee inherits person, and then in employee, we have a first name and a last name. Well, we just hid the first name and the last name from person. It's inaccessible because we didn't overwrite it, we didn't overload it, we hid it, is what we did. We actually have 2 versions of the same thing. So you're redefining it and you're making it into another variable. It's a different one. So you go in employee, you go and you set first name and last name. It's not set in person, especially if you said string first name, string last name in employee. You have 2 sets of first names and last names. One's in person, one's employee. That's terrible design. Don't do that. So instead, you overload the constructors to go back and set the first name and last name in the original set of data members that you have from the base class. In order to do that, you have to overload the constructor. You're overloading the constructor that sets the first name and the last name, and you're calling the first name, last name constructor from the derived class. So in the derived class, you're taking on information that you're not going to set. Instead, you're going to pass it back through the overloaded constructor. And the overloading part there is that little colon, and you're specifying the constructor from the base class that you're going to run. You send it all back, and it goes to the person, and it gets set in person. You don't want to set it in employee, because you're not setting it in the person, you're setting it in employee. Not such a good idea. And then you have people who don't know what they're doing. Java people, going back to Java. See, Java uses super, send it back. So they'll try and call person and send first name and last name back from an explicit call to person inside of a constructor that's in employee. I look at that and they go, oh, that's Java. No, it's actually, what is it? I was going to combine C++ with Java, but I don't think I can say it. That's like Schwava plus C++ plus Java together. Because you're using a Java method your Java format with using C++ syntax, or you're trying to use C++ syntax. But anyway, long story short, that's not legal. So you have to overload the constructor in order to send the information back to the base. If you make new variables in the employee, you've made new variables. You're not setting. If you do that on the final, you're not going to get any points for that. Long story short. I want you to overload constructors. I want you to send information back to the base class. Some people came in later looking at me going, what is she talking about? Class constructors. Class constructors is a member function whose purpose is to initialize the private data members. That's your formal definition. The name of the constructor is also always the name of the class. Never takes on a return type. Constructors do not have return types. None of them have a return type. So we have 3 different types of them. None of them. The name, the one that doesn't take on any parameters is the default. And it's implicitly invoked. Implicit means the programmer didn't do it. Explicit means the programmer did it. Programmer asked for it. So here's our specification and with a constructor for time type. And then here it is here. Time type, and we have 2 constructors. We have a default constructor, and then we have a constructor that takes on hours, minutes, and seconds. Time type is a data type that represents time, hours, minutes, and seconds. And then we have our hours, minutes, and seconds, our private data members underneath it. So this is an example of a class with 2 methods in it. So then we have the implementation. This is the specification, by the way. Specifications are function prototypes. So that's why we had that first assignment where you created day of week or something like that. You used a function and you created function prototypes. And that's because you do function prototypes all the time in C++. It's your entire your specification file is function prototypes. And then your implementation, here we have time type, colon, 2 colons, scope resolution operator, time type. And then we're going to set the time type. And time type is going to be hours is equal to 0, minutes is equal to 0, seconds is equal to 0. Default constructor. We didn't take on any parameters. So. And then here's another one where we have time type, which takes on hours, minutes, and seconds. And then in here we're going to set the hours to the integer hours, the minutes to the integer minutes, and then the seconds to the init seconds. So for the final, you'll be asked to write a simple class without using dynamic memory. No copy constructor or deconstructor writing will be required. Let me just check on that real quick, actually, because I did modify after I put this together. You have to write a base class. You have to write a derived class. No constructors and no deconstructors. Although you have questions on constructors and deconstructors, so you don't have to write one. Very minimal programming. Very minimal programming. So that's correct. You don't have to write one. But you want to know what a copy constructor and a deconstructor is in concept, because you have multiple choice questions and you have like a short answer kind of question that you have to fill out. Do we have any now I'm going to move on to pointers. Do we have any questions on classes or structures? Don't worry, this afternoon you're going to have some practice with it. So for those of you who came in late, the exam is not multiple choice. It's a combination. For those people who are having test anxiety already, you have an opportunity to pick up 15 points to apply towards the final exam by performing extra programming exercises that you'll be working on this afternoon in class after lunch. So, bottom line, you can pick up 15 additional points that you can apply towards your final. If you do all 3, there were 5 points each, 5 times 3, 15. So, one of them will be extremely easy, another one will be kind of challenging, the third one will be almost impossible, it'll be very challenging. All of them will have to be turned in before 3 o'clock tomorrow if you're going to use those points. I can't have you take it home and do it. If you're going to ace the final, you can do all of these assignments within an hour each. They're not hard. But most of you aren't going to be able to ace that final. Well, I shouldn't say that. That's a bad assumption. Some of you will, but a majority, I think. If you haven't done the assignments yourself, you can't ace that final. In fact, you're going to have problems with these assignments too, these in-class assignments. If you've done the work yourself, then this is not a no-brainer. It's going to be a piece of cake for you. Because if you can do this programming assignments for the course, then that's what this stuff is more. It's just different variations of the same stuff over again. So don't be stressed out unless you plagiarized all your assignments. And you're not going to perform very well on that final. All right, pointers. And you can't finish everything by 3 o'clock tomorrow anyway, because you won't be able to know it. You'll be giving me source code that's written in Java. Pointers. Unless we need a break. Do we need a break? Yes. Okay, because I know some of you have been sitting here since 9 o'clock in the morning. All right, let's take a, let's see, it's 10, want a 15-minute break? Okay, so we'll start back up at 11. Okay, so let me just pause this then. Okay, so I've had several people asking me at this break about the assignment. So let me just tell you, for those people who are not paying attention to me and they're just working ahead, let me just show you the what we're doing this afternoon. So you don't waste your time, actually. And I really don't mind, actually. I said that kind of sarcastically. I really don't mind. I don't assume that you're not paying attention to me. You're probably just multitasking. You know, you're trying to make better use of your time. Maybe because you've already know all this stuff and you don't have to worry about, you know, remembering what a class is or something like that. So if you click on the summer link and you click on Object-Oriented Programming with C++, and I'm actually kind of glad some of you are looking at this because it's helped me fix one of the links that was broken. So if you come down to the bottom here where it says Course Materials and you see In-Class Exercises, you'll see that there are 7 assignments out there, or 7 exercises that are out there. These are actually more advanced assignments. The way this is going to work, and after lunch, when we come back in, I'm actually going to go over all of them. Tell you what you need to do for it and show you some examples and stuff like that. But for those of you people who want to multitask, how this is going to work, there's only 3 total. So we have 2 groups. We have assignment number 1, we have assignment number 2, and assignment number 3. So you pick one. If you want to do this, you can get a total of 15 points. The 15 points that you're going to get are going to count towards your final exam score. They do not get uploaded into the EMS, you just do them. If you fail the final, don't worry, you got 15 points. Final's worth 25 points. So you can fail the final, you can pretty much fail the final and still get an A in the class by doing these 3 assignments, because you're going to get 15 extra points with it. The assignments are due, however, by 3 o'clock tomorrow, and they're emailed to me. So just these guys, and then I'm going to give you the syntax. So don't email me anything yet, because I'm going to give you a special syntax to use when you send it to me so I can keep track of who you are. Because what I'm going to do is after you take the final, I'm going to grade the finals. Then when I have the grades in front of me, I'm going to go to my email list, my saved folder, and I'm going to look you up by your student ID. So I need the format of the subject line made correctly. So don't worry about it. I'm going to give you all this stuff after lunch. But then I'll look you up by your student ID, see how many you put in, take a look at those, grade them if I have to, give you the points. Add it to your final, and then when I put the score in the EMS under your final. So these are final exam points that you're working on. Long story short, there's 3 that you complete. 1 of 1, 2, or 3. 1's probably going to be the easiest, but if you want a challenge, you might like the theme of 2 or 3 better. Number 4. So 1 of 1, 2, or 3. Number 4. And then 1 of 5, 6, or 7. So these are all on different topics. So this is, I think this one's recursion or something, or this one's on, I don't know, inheritance. Number 4 is on virtual methods. That one's not a bad one to do, actually. Friends and virtual methods and things. And I think one of them's on inheritance. These guys here are classes. This is a basic class. This is class inheritance. So if you want to challenge yourself, you want to demonstrate that you know how to do inheritance and you want to practice that, instead of reading a book or something, you can just work on this stuff. If you work on this stuff, and it will be this afternoon's activity. If you work on this stuff in class, then you're killing a couple birds with one stone. Number 1, you're earning points for the final, and number 2, you're actually learning more, I hope, you know, and you're practicing it, and at least by the end of this weekend, you'll have written a couple of C++ programs if you didn't write all that stuff yourself. You can also work together. You can work together in teams if you'd like, because then you'll be teaching each other, hopefully, what it is you need to know, what it is you're supposed to be doing. So if you're in the Oracle class, I'm trying to take the same approach as the Oracle one, but the only thing I can really have you do for C++ is write programs. So kind of like the activity. And it's much easier for you to sit down and just practice. Plus, it also gives you uninterrupted time that you can use to study for the final. You don't have any other work to do because all of the assignments have been turned in already. So you're pretty much done with the course outside of the final. So because you've done all the assignments and you just have the final left, it makes no sense for me to give you new information. So what I tried to do the first 2 weekends is give you all of the information for this course. And then this is the most oddly scheduled course on earth. It's like all the assignments are due already, and then we have a class meeting. Like 16 hours of class meeting. I'm thinking, well, that's kind of weird. It's like all you're here for this weekend is to take a final exam, really. So why not spend the weekend preparing for it? And it's my take on it. So, and then give you some points, because at least you're prepared for it. Some people are good test takers, some people aren't. So if you want 15 extra points, you got it today. But I can't take it past 3 o'clock tomorrow, which means you're going to do them today. It's only 3 programs, or 3 assignments. So some of the assignments are in multiple parts. You want to make it easy, do number 1, number 4, and probably number 7. It's actually pretty easy. So you can look at them all, review them all on your own. When we get back from lunch, I'll go through all this over again, so I can, kind of. But I sort of want to get through the final exam review. So let's go through the final exam review. All right, and actually in the assignments you've done are covered. So the assignments that you did for the class that were due on Thursday, that covered the material for the final. So the ones you're doing now are a little bit more advanced, a little bit more challenging. They're just different ones. So they're kind of a step up, yet they're also kind of overlapping. So pointers. All right, so a pointer is a reference variable. So a pointer holds a memory address of another object, and though the pointer we can indirectly manipulate referenced objects. So pointers are useful for creating links. So we have creating a linked data structure, such as a linked list. Used for management. In fact, one of the assignments activities is a linked list. You might enjoy that one, actually. Management of dynamic allocated objects. And functions as parameters types for passing large objects, such as an array. So you don't really have to know this for the final or anything, but know that arrays are implemented using pointers, and that a pointer is nothing more than a reference, and it's just like a regular old variable. So some people actually call them aliases, so it's like an alias pointer. Anyway, most languages use them. Java doesn't use them, so those people who write in Java code are going to be able to get that part. So we'll see. So I have some examples coming up, I believe, in terms of the pointer concept. Yes, so we will, before we get there, I want to cover the concepts of pass by value and pass by reference. So as mentioned before, you can use a pointer, you can use the addressive operator to a piece of large data and send that to a function instead of sending the data. It's easier, it's faster actually that way. Because you're not sending in that whole big old piece of data, you're just sending the memory address to that data. If you do that, then you can manipulate it inside of the function, and then whatever's at that memory address gets changed permanently. So not only do you not have to pass it in, you don't actually have to return it out either. So the passing back and forth saves you a little bit of memory, makes your program run a little bit faster. If you're not doing that, you're doing what's called pass by value. So pass by value versus pass by reference. 2 terms you want to be familiar with for the final. There's a couple of multiple choice questions that work with this concept, or at least one I can think of. So a pass by value sends a copy of the contents of the actual parameter. So here's the calling block, and here's the function called, and you're sending a copy. Well, it's the actual parameter. It can't be changed by the function because you're not actually sending the memory address, you're just sending the value that's associated with that memory address. If I said integer I, that's a value. If I said integer pointer I, that's a reference. So pointer I actually holds a memory address, doesn't hold a value. If I send a value, well, that's passed by value. Then the value gets changed inside of the function. A pass by reference is the exact opposite. It's sending integer pointer I. Take I as a pointer, put it into the function. The memory address is manipulated. So it sends the location of the memory address of the actual parameter to the function. And you can change the value of that actual parameter. So a lot of people do this so that you don't have to pass in, pass back out. Also, it might be useful for things like linked list and things, and for data structures that you're creating that use pointers to manipulate the data in a more automated fashion instead of doing it by, juggling a list. You're just looking at the memory addresses and you're just switching the pointers around or the aliases around, which is how a linked list actually works. So we know that the address of operator is the ampersand. This one here, it looks like and. I don't know where they come up with this ampersand. It's like and. It's like the at symbol. And it's actually an ACT directive in some languages, but anyway, long story short, the ampersand or the and symbol is the address of operator. So if I said to integer x and float number and character ch, and I said the address of this, you can use the ampersand in front of anything, and it always gives you the address of. If you do the address of a pointer, you're going to get the memory address of where the pointer is actually located, which is weird, because what you want is the value that's being held by that memory address, which is another address. So it's actually kind of funny how that works. If you want just the memory address, you just give it the pointer name. These are not pointers, these three. If I were to create this x into a pointer, and if I just printed out x, I'd leave the ampersand out, because I'd get the same thing. I'd get the address that's being held by x, instead of the address where x is located, because that's going to be a different value. That's going to be the address of the variable that's holding the value of the variable that I want to go get to, which isn't going to be as useful for me. So what is a pointer variable? It's a variable whose value is the memory address. So it's a memory address and location. So to declare a pointer variable, you must specify the type of the value that the pointer will point to. So here we have an integer pointer PTR. PTR will hold the address of an int. So that's the funny thing. Other languages, you don't actually have to give it a data type. C++, well, we don't have it in Java, so I can't compare it to that. Objective-C, you have to give it a data type as well. So, long story short, you have to give it a data type. Some languages, those two languages in particular. So integer character means it's going to hold a character, it's going to hold an integer, it's going to hold a float. So in terms of using a pointer type, believe it or not, I have these kinds of pictures on the exam as well. So the exam actually is not as hard as you might think it is. There's some easy questions. I think this is an easy question. This is an easy question because if you know how to use pointers, it's a no-brainer. So if I have integer x and I have x is equal to 12, if I say integer x, here we got 2000 and I label it x and I put 12 inside of it. So some of these stuff's going to be blank. Well, I'm going to give you the memory address. I'm going to give you the name. And if I said x is equal to 12, put 12 into something. I'm going to put it into this box, or am I going to put it in this box? Well, I'm probably going to put it in the box that's labeled x. So I'll put it over there if I were to ask you that. But that's too easy. I'm not going to ask you something like that. Instead, you're going to get something like this, but a few more lines of code on here. So follow, integer pointer, follow pointer, make it equal to this, or something. Where you'll get something where it'll be like a, kind of follow the logic around a little bit. You can get it. So it's not too hard. So here we have the integer pointer value, PTR. Well, it ended up down here at 3000. And then PTR is going to be equal to the address of x, so now PTR is equal to 2000. So because PTR holds the address of x, we say that PTR points to x. So they're really just two aliases for this memory address right here, 2000. So then we also have the indirection operator. So we have the reference and the dereference. Or the dereference is the indirection. So if I said follow PTR, so if I print out, if integer x is here and x is equal to 12, and I created this pointer variable PTR, and PTR, this is why you don't want to do the address of PTR, because you're going to get 3000. If you just print out PTR, you get 2000, because it's holding the address. PTR is equal to the address of x, and x is up here. And I'm going to see out, well, follow PTR. If I follow PTR, actually, good question for you guys. What's that going to print out? Yeah. I just gave it to you. So. Good, someone's paying attention. Thank you. 12. If you can't answer that question, I'd seriously consider doing those 3 assignments. You might just want to do them for fun anyway because you'll be bored. So. The value pointed to by PTR is denoted by the follow PTR. So here we have integer x, and then x is equal to 12. And then integer pointer PTR, same thing as before, have it equal to the address of x. And now follow PTR and have it equal to 5. If I said cout, my next line of code would be, cout x. And then the question below would say, the multiple choice question, and I'd say, well, what does x equal? 5. We changed it by PTR, we didn't change it by x, but it got changed when we printed it out. You know, there's actually another school that I teach at in C++ at, and well, you probably know, CSU East Bay. And there's a question, I gave you guys the question. I'm going to see if this works. I give these guys the question all the time. It's an undergraduate class too. You guys you should know this because you're graduate level, right? So it'll be an easy question for you. I give them the same question every time, and then I get at least 90% of the class misses the question. I think it's just hilarious. Every time I look at the answer, I go, wow, they missed it again, they missed it again. This is the fun I get out of it. I gave it to you guys, I'm going to see if you miss it. It has something to do with this indirect reference. You know, we change the value around, and I say, well, what's the value of x? And everyone picks the wrong one. They always pick the wrong one. I don't know. Why do you do that? Why do you do that? It's like, you know, they don't realize, they don't understand that the reference has changed it. They think it's a different variable completely, but it's a pointer. I mean, you can see it because this is in black and white. The question's not going to be as straightforward. But when you look at it, you'll go, and your first instinct will be the wrong answer. So for those people who came back from the break, that's why give me, read all the different options. Consider all the different possibilities. Don't just go with your first impression. Your first impression will be wrong on that one because 90% of my students said that. I'm going to see if you guys hold true to that statistic. You guys should be smarter than that. You guys are not going to miss it. So. It is amazing, though. You guys are smarter than the undergrads, but you should be. You're graduate students. There's some pretty stupid undergrads out there. Not to criticize, but... And I'm not talking about any particular school. I'm just talking about undergrads in general. Imagine they just come from high school. They don't really have that much of a background. You guys have been working in the field. Some of you do this for a living. I don't know. Some of you may not. I question how many people actually program for a living when I look at some of the programming answers and assignments. I don't know about this. Unless you guys plagiarize for a living, I don't know. Anyway, so I'm being sarcastic on plagiarism because I've already found several cases of it. Not, you know, it's just aggravating. So anyway, here's another example. A more positive tone here. So let's see, we got character C or CH. Here's the character CH. All this is doing is using characters instead of integers. CH is going to be equal to A. We can do that. And then let's make a pointer to the character. Character pointer is going to be equal to Q. And then Q is going to be equal to the address of CH. Well, now Q is equal to 4,000. Now follow Q, have it equal to Z. There we go, we got a Z in there now. So now CH is also equal to Z. That's the point I was trying to make from the previous example. And then, what if we do this? We could say P is equal to Q. Oh no, P is equal to Q. Well, P is also a character. So this works actually. It's a character pointer and a character pointer. P and Q can be assigned to each other, no problem. So now P is equal to 4,000. So if I follow P and have it equal to A, then character is going to be equal to A again. This is the confusion people get with linked lists all the time because, you know, they go, oh, I forgot to change the next, or I forgot to, you know, and then you forget where you are on the list, and you just break the list, and you've lost half the list at that point. So Anyway, so now P and Q both point to CH. So you can have more than one pointer. People use pointers so that they can have more than one reference to the same memory address, and they can manipulate it without having to pass the information all over the place. Okay, so for the final, you also want to be familiar with the new operator and also the delete operator, because you're going to automatically, dynamically create memory with this. So new data type, or new data type with opening and closing brackets for an array. So if the memory is available, if it is available, which usually it is, unless you have created a memory leak and you don't have any memory that's available anymore. If the memory is available in an area called the heap, or the free store, I call it a heap. There's some books that call it free stores, but it's part of the process space of the program that's running. You know, you load up the exe file, runtime environment of the operating system is going to allocate the heap memory. You got the stack, you got the code, the data. If you take an operating systems course, you'll be familiar if you haven't done it already, but I'm talking about the process space. So the heap memory is allocated when you say new. When you don't use the new operator, you're not using the heap actually, you're using the data that's below it. That's a different section of the process space, which is interesting. And that's controlled and managed by the stack. You have no control over it, which is also kind of an interesting point. But anyway, new uses the heap, and you can get the address of that and use that as a pointer. So dynamically, the dynamically allocated object exists until the delete operator destroys it. Nothing is done automatically on it. So in Java, we have this thing called a garbage collector. Garbage collector comes around and looks at the, well, we don't have any stack allocation of anything. Everything's always dynamic in Java. So that garbage collector goes around and picks up everything. We don't have a garbage collector in C++. That's another one of the questions I ask my undergrad students, because they hear about garbage collectors and they automatically think every language has one. The garbage collector of C++ does this, and then that's number A. Number B does that, number C does this, number D does that. Or the last one says does none of the above. When the answer is always does not, there's no such thing as a garbage collector in C++. So the answer is always none of the above, because, you know, but they assume, oh, there must be a garbage collector. She said the garbage collector in C++ does this. Number one, looks for all references that no longer are holding memory. Are going to be. Looks for memory that's been allocated but not deallocated. See, all those answers are wrong because there's no garbage collector in C++. But I didn't give you that because you guys are too smart for that. You wouldn't even fall for that question. Instead, you'll come up and say, there's no garbage collector, you know, Dr. Hager, there's no garbage collector in C++. I don't understand this question. So the question doesn't work on you guys, but it works on those guys because they think there's a garbage collector and everything. So. Anyway, I'm just giving away all the ways that I find entertainment in exam taking. I think it's just funny when people answer that and they go, ah, yes it does. It must be a garbage collector. She said there was. Actually, there's an entire art. Somebody put a book out recently. Last time I'll mention it. They put a book out recently, The Art of Exam Taking, where you can actually create an exam on basic questions, really easy questions, where one question will get you thinking the wrong direction for the next one. That contradicts each other. So like if you read all the answers to that garbage collection question, then underneath it was another question that like was the exact opposite. The reality was the exact opposite of what you just read. Then it switches your brain. It's like a mind game or whatever. So every time you answer a question, your likelihood of answering the next question correctly goes down. So that you're not going to answer them all correctly, because you're going to, by the time you end up done with that exam, you're like, what? Like, and the use of a pointer in Java. So now you're thinking Java's got pointers, C++ got a garbage collector. Okay. And then the third question that comes up, it says, you know, and I wrote this Java program for the iPhone. It's like, what? It's like, wait a minute, you can't use Java on the iPhone. Actually, you can, but it's not native. It's not native. There's third-party APIs actually right now. Because one student actually argued with me for the longest time. How come we have to write? This is the same thing that people in the Objective-C course are going to say. They're going to say, how come we can't use a Windows machine for object-oriented programming in Objective-C? I signed up for the class. How come I can't use my Windows machine for it? The language isn't supported on that platform? Oh, okay. Doesn't work with those libraries? Not part of Microsoft Foundation? Oh. Anyway, back to the review. We're almost done with it, believe it or not. So the new operators using conjunction with the delete operation. We have three kinds of program data. Here's the summary of what I was talking about in terms of static and dynamic for you. Static data is memory that is allocated and exists throughout the entire execution of the program. When I say integer I, it never goes away. It's static data. Well, it actually does go away. When main goes away, if I did integer I inside of main were to go away, program were to end, it goes away. If I declare a function, call a function, inside of the function I go integer I, when the function's no longer on the stack anymore and that goes away, then I goes away. So this is kind of misleading. It may not be around throughout the entire execution of the program, only while it's in scope. So if it falls out of scope, the environment variables change. Environment changes, it may not necessarily be in memory. And then we have automatic data. Automatic data is created at function entry, and it resides in the activation frame of the function, and then it's destroyed when the return happens from the function. Automatic data is stack entry data. So you load up the stack with a bunch of entries. That creates automatic data for you because inside of the function. So automatic data is another abstraction on top of static data, by the way. It's automatic because it's stack allocated, stack generated, static data. It gets allocated, it's in the heap data, it's not in the heap, it's in the data. It's on the bottom, the code data section that's on the bottom of the process space. And it's used, but when the stack goes away, it automatically goes away. So there's no control over it. So you know, when I think about it, everything that's not dynamic is always automatic data. And dynamic data is new and delete. It's what the programmer creates. So explicitly allocated and deallocated during the program execution by the C++ instructions written by the programmer, and it uses the operators of the new and the delete to control it. So dynamic data is always new and delete in terms of the concept. And here's an example of dynamic allocated data. So we've got a character pointer. Pointer is equal to new character. Follow the pointer, have it equal to B. Did that. So here's a character pointer. It's a memory address here. Follow it, have it equal to B. Okay. C out, follow the pointer. Dynamic data has no variable name. There's no variable name actually to this dynamic data. It just has equal to B. So, because we're going to follow it. Well, what address is it? Well, we don't know what the address is. The address is out here. So we can't actually get to this memory address. There's no name on the memory address. When the previous examples, when we said that pointer is equal to the address of X, there was a memory address. There was a memory address because X was assigned a memory address. And we said, give me the address of X. So now when we say new character, we get a new character. We get a pointer to a new character. Theoretically, PTR actually stores that address because PTR is a character pointer. It's storing that address. Well, what value is the address? If we reference it through PTR, we're good. But in the next line of code, if we say PTR is equal to new character, again, what did we just do? Memory leak? Yeah. We caused a memory leak. Because now we have a piece of pointer that's out there that allocated a new character. And we took the same pointer and now we had to point it to another new character. There's nothing. There's no way of referencing. It's an inaccessible object. Because we can't access it, there's no memory name associated with it. We haven't put a name on it. Not like X. But how is that different from integer X? Integer X is actually statically allocated. It's still memory. It's just a different spot of the process space. It's not in the heap. We're actually getting it from the static data that's down below. So do we really need to know that? No. We can actually use it the same way. But it is named memory. There's a name on that memory address, which is interesting. So dynamic data has no variable name, which is kind of interesting. That's also another tripped up data. If I were to put that as a true-false question, does dynamic data have a name? People go, yeah. Doesn't all data have a name? Yeah. Sure. There's like about 5 or 6 true-false questions. Make sure you read the question. Because what I'm going to use is the word dynamic in there. This is not one of the questions. Static in there, dynamic, pointer, non-pointer, reference, dereference. And then you'll be like, okay, sure. If you read it, if it sounds right, sure, true. Dynamic allocated data, again, just continue with the concept. If we delete PTR, you know we can still use PTR. PTR is still around. We just deleted what PTR referenced. Because PTR is a memory address, so we got rid of the memory address. But we still have PTR. PTR is still around. So we can that's why we go PTR is equal to null. So we can tell that it's null now. Other languages actually automatically create a null value for it. Or automatically, if this were done and then I were to not do new next to it, that would actually generate an error. Because it doesn't point to anything valid or invalid. It doesn't point to anything. Is it null? Not initialized. Java would actually make that null. C++ doesn't make it null. But you don't have to worry about that. A character, pointer, PTR. PTR is equal to new character. Follow PTR, have it equal to B. So when we first created it, it wasn't holding on to anything. We followed it, had it equal to B. We seed out it equal to B because we followed PTR, printed it to the screen. Now we delete PTR. So the delete deallocates the memory that was pointed to by a PTR. PTR is still around. The pointer up here is still around, statically created, never goes away. So that's called a, what is that called? What does this down here do? Delete PTR. Yep, creates a dangling pointer. So know what a dangling pointer is, an inaccessible object and a memory leak. There's questions on all three of those actually. But you guys know that already. So using delete, the delete returns the memory to the free store. Yeah, it releases the memory, makes it available to be reused. So it's previously allocated with new. So new and delete comes in a pair. The object or the array currently pointed to by the pointer is deallocated. And then the pointer is considered unassigned. It's unassigned, it doesn't automatically get sent to null. You actually have to do in the next line, say, okay, now this pointer is equal to null. Creates a null object out of it. So the operator delete, for the syntax, we have delete the pointer, and then we have delete if we have an array, which is actually kind of interesting, because an array, the name of the array stores the starting address of the array. When we use this symbol, and this was the pointer of an array, this gets us everything that array points to. So it takes the starting address and figures out the length in memory, which is kind of funny because you can't get the length unless you use the a different type of programming syntax for it and write a method to determine how big an array is. Otherwise, arrays don't have a built-in length to them. I mean, you can't figure out, if I made integer my ints and I gave it the size of 5, I can easily write into 6 or 7 or 8. There's no arrays bound checking. So how does that work? Which is kind of weird. It just, you know, so this, how are you going to delete 5 of them? Funny thing is though, it's stored, if I said, made it new ints, and gave them 5 ints, I actually get 5, new returns 5 memory addresses, and they're concatenated contiguously. So instead of being non-contiguous, which means they are right next to each other, and it knows that there's 5 of them. So the pointer's keeping track of it, which is actually kind of interesting. The regular array doesn't keep track of it. I asked the array, how many do you got? It's not going to come back unless I used a new with it. It's not going to come back and tell me there's just 5 of them. I never get the size of an array. So, alright, so, but that works because the new operator gives us a count. So if the value of the pointer is 0, there's no effect. Otherwise, the object or the array currently pointed to by the pointer is deallocated. And the value of the pointer is undefined. So the memory is returned to the free store, to memory. So square brackets are used to delete and deallocate. Delete and deallocate dynamically allocated arrays. So if you see the square brackets, you're dealing with an array, actually. And it works without the square brackets. You're just deleting the starting and you're creating a memory leak for the rest of it. It's still out there, you just haven't deallocated it. But it doesn't really matter if you don't deallocate something. 9 times out of 10, you're not going to have a problem unless it's a lot of memory. and you allocated a lot of memory but you didn't deallocate it, then you might end up with a problem after the program runs for about 5 minutes. Normally it's not going to have a problem at all. There's tons of people that use pointers all the time. No. Don't delete anything. It works. Actually, there's tons of people who write C++ programs, and when you write your programs this afternoon, you'll go, no. Why you gotta delete anything? So you can go no for a very long time in C++. It's only when you like do a program like implement like a database program in C++, then it's not a bad idea to run some deletes occasionally, get rid of the stuff you're not doing anything with anymore, because you will run out of memory eventually. It's just like you're not using enough memory for hello world and for very small programs to actually notice a difference. So here's an example for dynamic array deallocation where we have a character pointer, and here's the other thing too. So you know the examples that you've been looking at have been moving around the pointers. I don't like this. I actually like to put it, oh no, I like this syntax. The other one is what you put the character pointer, or what I hate is with a space in between there. So it looks like character times PTR. It's like, what? So this is the syntax I actually like. Actually, put it next to the variable name. Some people don't. They think it's part of the data type, so you put it over here. It just has to show up somewhere in between. So PTR is equal to new character 5. This is how we're going to allocate those 5. And we're going to string copy into PTR by, because we know that if it's a string copy, we're going to have a null character that's going to show up. So we're going to actually have 1, 2, 3, 4 characters instead. So we're actually going one extra. And then we can go PTR number 1, have it equal to u. So 0, 1. So it's BUE instead of BYE. And then delete PTR. So when you delete PTR, it deallocates the pointer, the array pointed to by PTR. PTR itself is not deallocated. The value of PTR is undefined. So if I went to the next line and said, okay, PTR 1 is equal to new, put this line underneath this line here, it still works. But what do we have? Nothing. It's not going to say BUE anymore. It's going to say something else. Actually, unless you've done new or delete, unless you've done anything else, you might actually get lucky 1 out of 5 times, or you might fail, but most likely it'll probably bring it back to you because it didn't change. Unless you've done something in the program to change what's there. It's still kind of there. It's kind of not safe though, huh? Doesn't give an error. Just the same way as I did, if I did PTR 12, there's no error. You'd think, but in C++, arrays aren't bound checked, which is kind of a, you know, so people complain about C++ all the time. They say it's unsafe. They call it unreliable. That's one of the reasons why. You can do things, if you can do something in the language that's illegal, that's wrong, yet the program still compiles properly and still runs. Nobody caught you on it. It's an unreliable language. So some languages are more unreliable than others. You're allowed to make mistakes and you're allowed to do illegal things on C or C++. So certain companies wouldn't use it for something because there's a likelihood that you're going to misuse it. And pointers are one of those things that people misuse all the time. So are arrays. Arrays are constantly misused. So here's a question for you. What happens here? We got integer pointer PTR is equal to new int, and we're going to follow the pointer and have it equal to 3. And then the pointer is going to be, oh, I just gave you the answer. Yeah. And then follow the pointer, have it equal to 4. Well, I got an inaccessible object. What happened to 3? It's gone. How can you get at it? You can't. It's inaccessible. Some people call it a memory leak. Some people call it an inaccessible object. Either one of them is fine. What you're going to see on the exam is some source code a little bit more complicated than that. And on the bottom it's going to say, what's the problem? Well, you got choices. You can either have an inaccessible object or a memory leak, or you can have a dangling pointer, or you can have both. Or if you're not with the program, you're going to put something else on there that says that the value of something is never assigned. So that's another one of those questions I get some interesting replies on. So the no-brainer, you only have a couple of vocabulary words to remember. Inaccessible, memory leak. Dangling pointer is another vocabulary word you want to be familiar with. So, all right, so here's our inaccessible object. To fix it, we say PTR2, just create another pointer, PTR2. Actually, linked lists leads themselves to inaccessible objects and also, dangling pointers. Why do you want to create a linked list instead of using an array? Why create and use a linked list instead of an array? Well, yeah, one of them's dynamic, the other one's static. Huh? Oh, I thought someone said something. It can grow, yeah. So, alright, so the linked list doesn't have any bounds. Neither one of them do bound checking. Neither one of them really have bounds associated with it. You're supposed to, theoretically, on the array, but you can write past it, or you don't have to use it all up. So linked lists are more memory conservative. You only allocate what you need. Also, the linked list grows indefinitely. It's a dynamic array, so you can make it as big or as small as you want. It's memory conservative. So people like the dynamic array or the linked list. And linked list is nothing more than a bunch of pointers that are pointing to information, nodes or variables. So you can get by without creating inaccessible objects by creating multiple pointers. You create multiple pointers with a linked list. Each one of the items in a linked list points to another item in the list, so it's memory pointing to each other. If you put the pointer inside of the memory, then you just have to make sure you keep track of all the memory you have, because if you miss one of the memories, you've missed everything past that piece of memory. And the funny thing is it's not stored like a list. It's not stored sequentially. The news create memory all over the place, but you have the illusion of a list, or the linked list. But you don't really have a list. You just have a bunch of memory that's all pointing to each other. So this is actually kind of an interesting concept. So making an object inaccessible. Here the 8 has become inaccessible. So this is another way of doing it where you have the 2 pointers and you had a really good thing going on, but you took this one and had it equal to this one. So PTR equals, so PTR2 is equal to PTR, or PTR is equal to PTR2. Well, you just did the same thing. You made it inaccessible. Inaccessible objects lead to memory leaks. Memory leak is the loss of available memory space that occurs when dynamic data is allocated but never deallocated. It leaks out of the... Where is it leaking out of? Actually, that's another question I didn't ask you guys, but I probably should have. So it's another undergrad question. It says in a memory leak, the memory leaks out to A, another program in the system, B, because it's a leak, right? Where does it go? It doesn't go anywhere. It's not that it's not going anywhere, it's just not available anymore. Or C, none of the above. It leaks out to another program. I can't remember what the other question was. It leaks out to the operating system. It doesn't leak out, it just gets stored for future use. I don't know, just different scenarios for where the memory goes when it leaks. Dangling pointers. There's a dangling one too, and I can't remember how that goes. Anyway, a pointer that points to dynamic allocated memory that's been deallocated. So a dangling pointer doesn't point to anything valid. So if I said a dangling pointer points to null, no, it's not pointing to anything. There's no pointer. It doesn't point to anything. It's dangling. Nothing, not valid. So it doesn't point to null. If you make it equal to null, you get rid of the dangling pointer. It's not dangling anymore. Or if you take a pointer that's dangling and you assign it to another pointer value, or you go new to it, not dangling anymore. So that's like the joke question. A dangling pointer is dangling because A, it's pointing to null. B, it's pointing to somewhere. It's pointing to this, pointing to that. When it's not pointing to anything. So. Alright, so we know what a dangling pointer is. Pointing to something that's not valid. We can create that by deleting. So the scenarios normally, the no-brainer scenarios, you're going to delete something through another pointer, and then the pointer that used to be pointing to it. What happened to that one? You say it's equal to null, it's not dangling anymore. Why is a destructor needed? Well, when you have a dynamic array, aka linked list. We don't have a dynamic array structure in C++ in the core class, core packages, or core includes core library. Like, what language are we talking about? In we didn't do the standard template libraries for C++. We didn't do templates, but we can actually create a dynamic array using. We can use it using third-party data structures, actually, that we can add in, libraries that we can include. You can create one using linked lists. You can use standard template libraries to create dynamic arrays. But in the core classes, there's no such thing as a dynamic array. Arrays are static in C++. If you're using the C version of it, that is. But when you have a dynamic array class, create a class, make a dynamic array class, which you can very well do, and it goes out of scope, the memory space for the data members of the size and the pointer of it are going to be deallocated. So any memory that's been allocated will be deallocated if you delete it. If you delete the object, and inside of the object you have a destructor, then any memory that that object is pointing to will also be deleted by the destructor. You actually have to write lines of code in the destructor to delete anything that you did new with. Which is actually kind of funny because you show students a blank destructor. Here's the default constructor. Is there such thing as a default constructor? No. Why would we have? We only have one. We only have one destructor. If we have a default, it usually means we have more options than one. That question is not on the exam. You don't have to worry about it. But if you think about the concept, there's only one copy constructor, there's only one destructor, there's multiple constructors, but there's only one possibility. So inside of the destructor, you're never going to have one that's blank by default, or you're never going to have one that takes on parameters either. Deconstructor never takes parameters either. What are you going to take a parameter for? What are you going to pass to it, even if it took on a parameter? What are you going to send to it? There's no need to ever send anything to it. So inside of the destructor, you're going to have delete this, delete that, delete this, delete that. You don't ever create new anything in a destructor unless you want to create some memory leaks. So the dynamic array that the array points to is not automatically allocated. So inside of a linked list, what do you got? You got a linked list structure, and it's making new nodes. You delete the linked list, doesn't delete the nodes. So if the linked list has a destructor that deletes all the nodes, it goes through the whole node list, deletes all the nodes. That's why you have a destructor, because you want the list to delete the nodes in that particular case. So you don't have a class object that's creating any memory. There's nothing to delete. No need to have a destructor. Senseless. So you don't, a destructor and a copy constructor, not required. Is a constructor, well, this is a tough one for me to answer. Do you have to make a constructor in a class? The rules are different between Java and C++. Java, you're required to have one, a default if you inherit. Or is it the opposite way around? Java doesn't require it and C++ does. They're different. They're not the same. In one case, you can't inherit. You can't overload. No, it's like, I don't believe you can. In one case particular, I think it's C++. This is not on the exam. It's kind of a trivia question. Maybe I'll look it up after lunch. In the languages differ actually in the constructor requirements. One actually, in certain situations, actually requires it. It's best practice in all languages to create at least a default constructor.
In Java, you have to send super.
You have to, yeah. I believe it's Java that actually requires it, and C++ doesn't require it. I have to refresh my memory on this. One of them, you can do it as long as you don't inherit. If you don't inherit anything, you'll never need a constructor. But once you start inheriting, one of the languages will crash and bang on you. Won't compile or work correctly because it needs you to explicitly declare the constructors, otherwise it can't construct the object. I want to say it's Java, but I don't know. I'll have to look that one up. But it's good practice just to have a default constructor because the language might require it. So I don't think you need one. You don't need a constructor at all in Objective-C, the initializer. You need an initializer. Actually, you don't need an initializer either. You can just call the super initializer constantly. So, for those of you who are going to take the Objective-C programming class next, that one's a fun one. Everything you learn from C++ or anything you learn from Java, just throw it out the window. Totally different language. And then they don't like constructors. Objective-C, there's no destructor, constructor. There's no constructor, copy constructor, or deconstructor, but there's this thing called an initializer, and you got to allocate memory, which is kind of weird. So, I think I'm teaching that in the weekend program next time. If I have this correct. Objective-C. Are you taking it? You took the iPhone class, but you didn't take the Objective-C. See, now you'll go, oh, that's all that stuff was. So anyway, yeah, better to take Objective-C before you take iOS application development. But anyway, it doesn't really matter. So let's see. Yeah, you don't have to worry about it. Actually, Objective-C is easy because there's fewer rules and all this crap that you have to do for C++. There's no friends. Don't make friends with Objective-C. You don't have to worry about virtual. Everything's dynamic. There's no static versus dynamic anything. It's a lot simpler. It's a cleaner object-oriented implementation, and it's also based on C. So just like you can write C code in C++, you can write C code in Objective-C. Same identical syntax. So anyway, back to C++. Why is the destructor needed? To allocate memory that's been allocated, to deallocate memory that's been allocated by the object. It does not deallocate the object. Delete deallocates the object. The destructor deallocates the memory that the object created. So in here we have the destructor. It has a little tilde sign in front of it. It looks like a default constructor if you take out that tilde. So it looks just like the default constructor, but it has a tilde on it. And we have in here delete. All you see in a destructor are deletes. You're not going to allocate anything. Alright, so for the final exam, you won't. This is wrong. You don't have to worry about that. Don't look at that. I need to edit this thing. Well, there's multiple versions of this exam. I gave you the one this time that has a little bit of source code writing. So, questions on what's going to be covered on the final exam. What I did is I just went through all of the topics. If I didn't talk about it, and one of the things I didn't talk about was virtual, you don't have to use virtual. Although if you want to practice with virtual in abstract methods and abstract class concepts, one of the activities that you can do this afternoon will be based on that. So some people might, for some people who want to really learn and improve their C++ skills, can use the opportunity to do one of the 7 that, maybe like number 4. That has, I think it's number 4. That's the choice. We'll have you work with virtual. And there's actually lectures on it in the bhacker.com website. I don't know if I covered virtual in the last session, but I'm not covering it on the final, so you don't have to worry about that. But if you can figure out how to do it, it will improve your understanding. It's the only object-oriented language that has that virtual kind of concept to it. And if you're not familiar with what I'm saying, in C++ we have object inheritance from abstract concepts, like we have in any other object-oriented language. But in C++ we have to explicitly say which set of methods we want from the overloaded groups of methods that we get. And when we use virtual, requires as a pure virtual method, is a pure abstract method, requires that we implement it, and then we can pick which one we want when the object actually gets made. So when we get back from lunch, I'll go over the assignments or the exercises, yeah?
So like these methods are only virtual and the class is not abstract?
No, it could be abstract. It's just not pure abstract. It's pure when you have a virtual method and it equals to 0.
What is the difference between abstract and pure
Abstract,
abstract?
if it's pure, if you have a pure abstract class, which is different than any other language, because in Java, if you have something abstract, you have to implement it or leave it abstract. C++, you make it pure, it's required that you implement it. You can't leave it abstract. There's no such thing as an abstract after that. You have to implement it. So, actually, you know what I'll do is I'll go over virtual methods. I'll do that after lunch, actually, because I don't know if I covered it last time. Did I cover virtual? Did I cover it? I did cover it. Wait, I don't remember. This was actually like a month ago, the last time we had a class. Well, then if you say I covered it, I won't bore it with you again, but something that's pure has an equals 0 next to it, It means you are required. Under no circumstances are you not able to leave it abstract. You have to implement it. There is no implementation if you don't implement it. If it's not pure, you can leave it. You can leave it, and you don't have to implement it. Which, in Java, if you leave it, you have to make it abstract again. So everything's abstract, 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 abstract until you finally implement it. C++, you can have stuff partially implemented, stuff that's, required to be implemented. So if I created, because we have no interfaces in C++, so virtual kind of gives us that interface component. And an interface in another language that has interfaces, you are required to implement those methods, even if they're blank. You have to implement that method. If you don't implement the method, you don't abide by the interface and it won't compile. So you take a language and take out the interface concept. What are you going to do? We'll put virtual in there. Make it virtual, turns it into a requirement. It enforces the protocol that it must be implemented. That's the only thing it really does. That's a pure virtual method. It can be virtual but not pure. If it's virtual, it means it's going to delay. The word virtual means delay the creation of the method until dynamically chosen. So if you reference the object like an employee, you'll get the employee version. If you reference the object like a person, you get the person implementation. Virtual waits until you reference it. Without the virtual, you get whatever, you get person and employee. And then if you created the reference as an employee, you're going to get the person. You have to manually go back and forth between which one you want by object casting up and down the hierarchy. Cast the object from an employee to a person. If you're doing it with virtual, then the later one, you create it, you reference it like a person, you're going to get a person, reference it like an employee, you get the employee. It creates the employee for you. So you don't get those rare cases in which you referenced it like a person, but you got the employee implementation of that method instead. That's the problem. So they say, oh, what happened with that? Oh, let's just make it virtual. So you add that keyword virtual in there, and all virtual does is say delay the creation of that method until the final object's been created. And so we know what we're referencing it as, and then use that one. So it dynamically chooses by the reference which version of the method. That's the virtual. If you want to make it pure virtual, you're just adding on that separate requirement. It says, oh, you have to implement it. Because you don't necessarily have to implement it if it's not pure. Doesn't really matter. But purely virtual doesn't exist. Virtual could exist, which is kind of weird. It's only a C++ thing. Other languages never have that. It's like other languages don't have friends either. So, good question. I can also help everybody as we after lunch. I can go around and help you and answer more questions as well. So let me stop this recording. This is the final exam review for the final exam that will be held at 3 p.m. tomorrow for this class. You don't have to bring anything with you outside of a pen as well. No extra paper or anything. No notes, no internet for this exam. So.